Hello, this is the Math 159, Gould, Chapter 2, Section 1, section about visualizing variation and numerical data. Okay, so remember that there are categorical and numerical variables, so this is only going to be about a numerical variable. So when dealing with a numerical variable, one often wants to know the typical, usual, and these are all synonyms, or common value of the variable. So what do I mean by that? So let's just come up with an example here. Let's say that your variable is, I don't know, height. So what you have is a bunch of heights. I'm just going to make, these are going to be in centimeters. I'm just going to make a bunch of them up. 172, 153, 164, 181, 197, 155, 166, 158, 189. Okay, so here's a bunch of numbers, right? This is our variable. And what we want is a single number, which we will call the typical, usual, or common value of the variable. So what do I mean by that? So basically what I want is a single number which summarizes all of this data. So like maybe you heard the term average before. Average is another word for typical, usual, or common. So we're saying, like, given all this data you have, hey, what would be a normal, average, or typical height given all these people that we have? So since we usually want to know what's typical, usual, or common, on the flip side of that is that there is the unusual / uncommon values. So if you know what's typical, you also know what is unusual or atypical. Okay? So why would you want to do this? Well, one of the things that we often want to do is segment our sample into groups and then compare the typical values of the groups. A common thing for this would be, hey, like, take your sample and break it up into male and female. And if you were to do this, you would see that the typical male height in America, at least, is about 185 centimeters, I think. Whereas the typical female height in America is like 160 centimeters. I don't know, I'm making these up. But either way, you can now compare the two groups if you have a typical value for each of them. Okay? So remember how this works. Somehow what we're doing here is we're making a summary of our data. We're taking all of the data, and then we are compressing it all into a single number, which we're calling the typical value. Okay. And when you're doing this, what we're doing is we're coming up with a summary value for the distribution of the variable. So whenever you want to somehow look at all of the data at once and summarize all of that data, we call all of the data or the distribution. Okay, we want to say something about all of the data. Like, we don't want to look at all those individual heights, 172, 153, and so on. We want a single number that says, hey, given all that stuff you had, your data typically looks like this. Let's talk about the distribution of the variable. Okay, when you're doing this, when you want to come up with these summaries, graphs often help. Okay, and what will happen is that usually the graph will sort of help you figure out that summary value. Okay, so we're going to do an example here. So 1 second while I change my screen. Sorry for being slow. I can't There it is. Okay, here's our Pokemon data. There we go. And let's change the size a little here. There we go. It should look a little easier to read. Let's change it more like that. There. Okay, now you should be able to see it a little better. Okay. So, the first graph we're going to look at is called a dot plot. And StatCrunch can actually make it for you. Okay, so if you want to make a graph, oops, sign in. Crap. No, StatCrunch, why are you doing this to me? Okay, 1 second. Okay, we're back. I got it working. Okay, so when you want to make graphs, surprise, surprise, you go to here, it says graph. And the first one we're going to look at is the dot plot. Okay, so let's choose, we will look at, how about, we'll do the speed variable. Or no, let's do HP. Okay, cool. So let me show you how the dot plot works. Okay, the dot plot is pretty straightforward. On the x-axis, actually, let me see if I can copy this. Copy, oh good, and I'll be able to paste it over here. No, that didn't work. Options, copy, click the image below to copy it. Oh. Okay, so we're gonna switch back to what's it called? Sorry, so slow. Back to the notes so I can write on this. Where did you go? There you go. Okay, there. Okay, cool. So there's a copy of the image. So you should be able to see it now. Okay, so I'm gonna zoom in a little. Show a lot. Okay, so on the x-axis here is my HP variable. And you can see it starts at 0 HP, 50 HP, 100 HP, 150 HP, 200 HP, and so on. Okay, and then you can see these dots. So this dot right here, it's above 0, which means that that dot is one Pokemon that has 0 HP. Let's look at all of these dots right here. So all of these dots are stacked on top of each other, which means that they have the same HP. And you could see if this is 50 right here, that's probably 51, 52, 53, 54, 55. Here, so because I'm counting from here, 50, 51, 52, 53, 54, or sorry, 50, 51, 52, 53, 54, 55. So what this tells you is that there are actually a lot of Pokemon that have 55 as their HP. And if you wanted to figure out exactly how many Pokemon have 55 HP, you could count these dots. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So because there are 38 dots, that corresponds to there being 38 Pokemon that have 55 HP as their HP rating. Okay, so you can see that it allows you, this graph allows you to look very quickly at all of the data. Okay, I'm going to switch back to Safari so we can go look at StatCrunch, or sorry, Chrome. Okay, there we go. Bring it back up. Okay, so when you're doing this on your computer, it's a little easier because you could hover over things and select them, and it will even show you which Pokemon those are. So you can see all I did was select those dots. I hope you can see this. I clicked and I made a little box to select them, and it highlights them, and you can see that, well, what Pokemon are we dealing with here? Actually, it's 60 HP apparently. So all of those Pokemon have 60 HP. So looking at this, you can get an idea of what's most common, since this is the group of these are the dots. So you can see that those dots are stacked the highest. That means that's the most common or typical value. So commonly, Pokemon have about 60 HP. You can see that that is the most common, so that's one way we could talk about this. Okay, so the dot plot is pretty useful. Now you can see that the HP goes all the way from 0. It starts off at 0 over here, all the way up to around 250 or so over here. Okay, so HP can go between 0 and 50, and most commonly is about 60. Okay, now there's another graph that will help you look at the distribution of a numerical variable better. You can go to graph. What we want is the histogram. So it says histogram. Let's select HP again. Click compute. So the histogram looks a lot like the dot plot. But instead of there being a single dot for each Pokemon, what happens is that the Pokemon are binned. Okay, so you can see this box right here. Basically, you can see that it goes from 0 to about 50, and that box is halfway in between, so this bin is from 0 to 25. So what happens is that all of the Pokemon that have from 0 to 25 HP are included in there. Now the next bin will go from 25 to 50. And then the next bin will go from 50 to 75. So in a histogram, and I'm going to go back to write this so you can see what I'm talking about. And I'll make a copy of the histogram in a moment. Well, here's OneNote. There it is. Okay, so let's talk about the histogram. So a histogram is like a dot plot, but instead of a single dot for each subject, subjects that have similar values are placed into bins together. Okay, now these bins all have equal bin width. So in the Pokemon example, the bin width was 25. So what does that mean? It means all of the Pokemon that have from 0 to 25 HP are in a bin together. All of the Pokemon that have from 25 to 50 HP are in a bin together. All of the Pokemon from 50 to 75 HP are in a bin together. Now you might be wondering, well, what happens to the people who have exactly 25? Well, you might remember this from previous math classes. You can see that this is a square bracket, and then this is a parentheses, so the 25 is not included for this group, and the 25 are included in this group. So the number on the left is included, the number on the right is not included. So anyone from 0 to less than 25 is in the first bin. Anyone from 25 to less than 50 is in the second bin. Anyone from 50 to less than 75 is in the next bin. Okay. Now what happens is, so they get placed in the bins together, and then the height of the bin is equal to how many subjects are in the bin. And we call this frequency. Frequency is the count of how many people are in that bin. So let me make a copy of the histogram from StatCrunch so we can look at this. Paste the image right here. So here's our histogram. And this is the bin right here that goes from 25 to 50. So you can see the height of that bin is about a little more than 150, which means that there are about 150 Pokemon with HP between 25 and 50, not including 50. Now the next bin goes from 50 to 75. And you can see the height of that bin is around 350. So there are about 350 Pokemon that have HP between 50 to 75, not including the 75, and so on. Okay, remember the bins are all the same, so they have a bin width of 25. Okay, so the histogram is pretty useful because if you go back, let's go back up to the dot plot. The dot plot's sort of hard to read because you're like, remember we were looking at this group of dots right here, and we're like, I don't know, that's like somewhere around 55. It actually ended up being 60. and it's a bit hard to count all of those dots because there's no markings over here. So the histogram is better than the dot plot because it's labeled really nicely. The frequency is the height, and then you can still see that it's HP on the x-axis. And then you can work backwards. You can see that this is 0 over here, this is 50. The bin stops halfway in between, so you can tell that it goes from 0 to 25, and then 25 to 50, and then you know it goes from 50 to 75, and 75 to 100, and so on. Okay. There's one more graph that we need to learn about, and it's called the stem plot. Let me go back to StatCrunch, and I'll show you how it works. Actually, let me just type, first of all, it's called the stem plot. Okay, so let's go back to StatCrunch. Okay. So if you need to make a stem plot, again, you will go to graph, because we're making a graph. And then it's called the stem and leaf graph. Choose the variable that you want it to make, HP. Okay, and then the stem graph is sort of like a dot plot. So what happens is these are called the stems over here, the 0, 0, 1, 1. So, and then every number over here is like a dot. So that means that this number is 0, 0. The next number is 0, 1. The next number is 0, 2, and so on. The 1 over here means that we've moved up to 10. So the next number is 1, 0, that's 10. 1, 1, that's 11. 1, 2, that's 12. The next number means that it's 100, so this would be 100, and so on. It's hard to read. We barely use them, but basically each number on the right is like a dot. The number on the left tells you the numbers before that. Okay, thank you. And this is the end of the video.